Hey everyone, welcome to the first webinar on open source software put on by the SEG Near Surface Geophysics Student Subcommittee. This webinar series is intended to help the community learn about different open source software packages that are useful and lots of people in the community use, both in academia and in industry. But before we get into the actual open source software packages, we decided that the first webinar should be on just the basics of Python and how to use some of these, basic sort of coding tools. So with that said, I'm going to pass off to Chris, who's going to do some introductions and then give a little presentation on the basics of Python.
All right. Thanks so much, Noah. Welcome once again, everyone, to our first workshop for open source software. I know I've included some bios in the original link, but the three of us here, Joshua, Noah, and myself, all have a significant amount of experience with using Python in geophysical settings, and also just for overall data management. And so we're happy to kind of bring in some different perspectives and some different skill sets to kind of get people going and getting metaphorical feet wet with what really is one of the more widely used and popular programming languages that we see in the geosciences. So let me just get all of this going here. All right. So like I said, this is the first of our webinar series on open source software. Just to kind of give a little bit of an outline on how this workshop is going to be going. The first thing we're going to be starting off with is this little introduction to the how to use Python, how to set it up, the different forms it can take, and how you're using it on your system. Feel free as I go through the presentation, if you have any questions, you can throw them into the chat or into the should be a Q&A function that you can throw some stuff into. And then after the presentation itself, we'll take some time just to address any questions that pop up. After that, the three of us will be running through just kind of some generic demonstrations of two of the ways that you can view, edit, and run Python codes. And we'll talk about some introduction to those in the presentation, but this will, after the presentation itself, become a lot more interactive, a lot more back and forth. And then Joshua will be finishing us up with just some basic talk about the syntax of Python code, how it's structured, how the different data structures that can exist within it, and the different data types, just kind of get people used to some of the terminology that Python uses and some of the ways that the data can exist within a Python code. So I'm sure some of y'all are already very well aware of what Python is, but I want to at least kind of give a little bit of an intro. Python is open source programming language, is fully open source, meaning that you never have to pay anything. It's open for collaboration, for people to submit changes or bugs that you can work on. It's a very collaborative community effort. Python really in and of itself emphasizes kind of an easier readability of code. If you have seen different programming languages and Fortran or C++ or other stuff, they might not, you look at a block of code and you're like, okay, this isn't quite all that intuitive. I'm not 100% sure what I'm looking at here. Python tries to be a bit better about that. Obviously, if you're new to coding in general, you still look at Python code, you're just like, this looks like gibberish. Once you kind of start getting a little used to how Python functions, Python syntax looks, it can become a lot easier to really, be able to read, look at a block of Python code and at least get a general idea of what's going on. Python itself is used in a lot of scientific fields, primarily for data processing and visualization. There are a lot of third-party softwares that we'll actually be talking about in future workshops that allow you to model and invert geophysical data. And then Python is also very compatible with a lot of applications of machine learning algorithms. So, in the field of geophysics in general and geosciences, with machine learning applications really becoming more and more popular and more desired to automate and help with the, kind of like make more predictions based off of what data we get. Python's really become a very popular tool to apply some of these machine learning algorithms. Currently, most stable version is Python 3.9. Some you don't really know about you don't really need to know about this part. Some older packages might still use Python 2. Don't worry about those. Get them out of there. Python 3 really becomes the industry standard of here's the most, stable, usable version of Python that we're working with. So why use Python, right? First off, it is compatible with all the major operating systems. If you're running Windows, Mac, Linux, anything, it's easily installable and usable on any of them. So no matter what kind of preference you have for your operating system, Python will work with it. It is widely used in academia and in industry. During this year's SEG annual meeting, Image, we had a panel where students were asking a panel of experts just kind of their thoughts on certain things. And one of the questions that was asked was, what skills do you feel are really up and coming in geophysics? And the most widely accepted answer was coding, specifically with Python. It's a very powerful and very widely used tool. And so being able to have this introductory experience to even just be at least a little bit comfortable with it, it's going to be a huge asset. Additionally, since it's open source and has a lot of purposes, a lot of applications, and has a very large user base, there are a bunch of online forums, guides, resources available on the Python website itself, on coding websites. If you just search, I'm having this problem in Python, you'll have thousands of hits of discussions of people having the same problems. It is capable of performing some very high-powered computing processes. Some of the softwares that we'll be looking at in future workshops that require very computationally heavy processes, Python is able to work with those. If you are doing a big data inversion and you need to use a whole bunch of hardware to get it to go, to get it to do it not in 5 days, Python is capable of helping with that. So kind of going into this, really two main methods to install it. There were some links that were included in the registration site. So some of y'all, once again, this might be a bit of a review, but I just want to make sure people feel comfortable with this part before we, really jump into it. You can install Python just as a basic installation. It just installs the Python interpreter, which is essentially, it's like a terminal-based thing where you bring it up and it's just a blank screen and it says, hi, this is the version of Python you're using. And then you can use it to run Python functions, or you can use one of the more commonly used methods is installing this package manager called Conda. And we're going to get into that for a little bit. For the basic installation, it's really as easy as going on to the Python website and downloading it. It's very bare bones. Like I said, you're really just getting, here's something to interpret a Python function, and that's it. Any additional packages, software, whatever you want to throw in there will have to be installed and activated separately. As far as new users are concerned, especially if you're not used to coding, would not recommend doing it this way. It can just be a little bit of just yep, okay, you have Python, now what? But it is an option. Now, before we kind of go into installing Conda and package managers and all that stuff, I kind of want to take a little bit of time to talk about the terminology that we're using here. So first off, the very top, right, all what we're working with, what all this is based off of, Python, the programming language. Just, this unique programming set of programming syntax and structural rules that allows you to put something in and get a machine generated output. That's all it is. Next, you have what we refer to as packages. These are essentially sets of functions and operators, that use the Python programming language, but are dedicated to a specific purpose. You have stuff like pandas, which allows you to, it's a package that allows you to more easily manipulate and work with data sets. You have NumPy, which deals with allowing you to do more complicated or high level numerical functions and mathematical operators. You have matplotlib, which just allows you to work more on the data visualization part of it. So a package is really just a collection of Python functions and operators that allows you to do something specific. You then have Conda, which is a package manager. It's just an easy way to set up a Python environment where, if you were to run a terminal, bring up just a blank terminal screen to start typing in, run this function, it already has all the packages that you need or that you want already installed, accessible, ready to go for when you want to run a Python function. In addition, there's one step below this where Conda has two what are called distributions. And this is really talking about how the software itself is using Conda. We'll talk a little bit about both Anaconda and Miniconda. It's really just a software that has a unique form that calls upon some base process, some base code, in this case, Conda. So let's talk a little bit about installing Python using Anaconda. Anaconda is a very robust and very straightforward distribution of Conda. What it is you install essentially this GUI, this graphical user interface that allows you to more easily look at and manage all the different packages you have in your Python environment. In addition, it also allows for some very easy installation of a couple of other Python-based softwares that allow you to look at and edit and troubleshoot Python code more easily. It is very large to download. The base environment that you get set up with comes with or installs over 300 packages, but has is able to easily install up to like several thousand more. But it is overall just very easy to set up. As far as we are, as far as I'm concerned, and I think Noah and Joshua will back me up, at least as far as new users are concerned, this is definitely a recommended way to go if you have the hard drive space for it, just because you don't have to worry so much about installing individual packages, because then you have to figure out what individual packages you need. It really just kind of takes a lot of the extra guesswork out of it, as long as you're able to take the time and hard drive space to install it on there. Then you have Miniconda, which is it's still using its package manager. It's still kind of taking everything you need and putting it to one place, but it really only installs Python, the files to do the whole Conda package manager, and some basic packages that people will need just to more easily install some other stuff. Once again, it's actually pretty quick to install. It takes a little bit more work to kind of adequately set up your first Python environment with it, but it's good if your computer doesn't quite have the adequate disk space, the adequate storage space to install Anaconda. We definitely recommend this over just using the Python and Python, the basic install Python, here's a Python interpreter, but it can require a little bit more effort, which might be a little bit off-putting to new users. So once you have your Python environment set up, right? Once you've installed Python, once you have a good idea of what packages you want to use and have those installed into your environment, next up kind of comes into, well, how do you what's the best way to write, save, edit, troubleshoot, run Python codes? And so we have three what are called integrated development environments that you'll see right off the bat when you install Anaconda, that are widely used within Python communities themselves, but also especially within the geosciences. So we have Jupyter, which we'll talk about all these in a little bit more detail. Then we have PyCharm and Spider. So each one of these three has unique features that make them very appealing to both new and advanced users. Each one kind of has their pros and cons as far as, oh, here's how Jupyter is better for new users or better for advanced users, and so on and so forth. All of them can run Python-based files, where if you see any file that ends in .py, or I think there's a few other things that go with it, like .pyx or something, all of them can run those, and all of them can be run using Conda. What this really means is that if you install Anaconda, and we can see, it'll show a little bit of what it's supposed to look like once you open up the navigator. If you run one of these environments within, or one of these IDEs within your Python environment, it'll run that software, but with all of the packages that you have installed in that environment ready to go. Something that can occasionally be a little bit taxing with using Miniconda or just with the basic Python environment is you're ready to run a Python function and you realize it uses a package that you don't have installed yet, so you have to go and you have to install it and then call it and make sure it's all working, and then you go and run a second function and like, okay, it has 2 or 3 other ones that don't have installed yet. Anaconda, and I guess Miniconda as well, does make that a lot more easy to work with. It's a lot, there's a lot fewer attempts to run a function and be like, okay, hold on, I need to go and download this package first. So we'll at least get to see some examples of Jupyter when Joshua and Noah do kind of run through a demonstration of how to use it and what it looks like. There are two programs that use this whole Jupyter interface, which are Jupyter Notebook and Jupyter Lab. How this works is that both of these programs open up a tab in your, whatever your default browser is, that basically connects it to just like a local host IP address. And because of this, actually allows it to be very supportive of HTML code. Don't really have to worry so much about that. If you're starting off, you're probably not going to be doing much HTML coding in Jupyter, but it allows you to basically set up these links so that you can easily, make like a table of contents in your notebook and be like, oh, you want to fast forward to this section, click, boom, there you go. What's really good about Jupyter is that the structure of it allows for this easy transition between very descriptive text and blocks of Python code. So what you would have seen if the video was working is essentially these, almost like this, almost like a layered tutorial where you can be like, okay, we're at this section now. Here's a description about how this code works and the variables that you're using in it. And then it'll go to the block of Python code and you'll be able to run it, see how it works, have it generate some kind of output so you can verify that it ran. And it's this very, very intuitive and very, helpful way to not just describe the code that you're using, but also present it. If you were to bring in, if you have like a Jupyter notebook file that you use for a lot of like your electromagnetic data management and processing, you can still use that as like a Python file and still like input different data sets, but then you can already have this detailed explanation of it there and ready to go. So that if you want to show that off to your, a manager or an advisor or someone, one of your peers to kind of walk them through it, it allows it for, it allows it to have your code to have this very helpful flow. There are also several what are called widgets that are available that allow you to do some more advanced data visualization and add some other functionality to your Jupyter notebook. There we go. A few pros and cons. So like I said, it's an excellent resource for coding tutorials, just because, like I said, it can give some adequate background and support and description to whatever code you're using. It allows for, like I said, some very ample describing and presentation of your Python code. And one thing that I think kind of gets overlooked is that the way that Jupyter notebooks are set up is that it really does encourage splitting your code into separated blocks that can be run separately, which as you start to get into coding and start to get some more practice with it, you'll find that trying to troubleshoot a code that's not working when it's just running one huge block is a lot more frustrating than splitting it into different sections and being able to be like, okay, at this specific, with these specific 4 or 5 lines, there's a problem here. And then making sure that works before going on. Some cons that we'll, talk about a little bit more is that, as you'll see in one of the other softwares we'll be talking about, there's seeing what variables, what different parameters are stored in your Python code that are able to be accessed. You're not able to see that as easily or as instantly in Jupyter notebooks as you are in Spider, which the other one we'll talk about. And it does struggle when you don't have an active internet connection, just so you're able to access and save Jupyter notebook files. Joshua and Noah, I think there might be, I'm not sure if there's a way around that. I'm still relatively new to Jupyter notebooks. I just know that's something that's given me trouble in the past. When they talk about it more, I'm sure they'll be able to say Chris was absolutely wrong about that. So we'll see that. Spider is another IDE that we'll talk about. We're really not going to be spending much time talking about PyCharm, which is the third one that we looked at, just because It is pretty similar in structure to Spider, but it, first off, I don't think any of us have that much experience with it. And also it's a little bit more leaning towards, using Python for like code development purposes, as opposed to Spider, which I feel works very well for just the whole data management side of the geosciences. So Spider, as you can see, can look a little bit more overwhelming right off the bat. Its huge strength, though, is its ability to handle multiple data sets and visualize them very easily. When I do my Spider demonstration, you can show off this feature, the Variable Explorer, which allows you to see what different parameters and variables are stored as, get some details on them, in a very just like easy way to see, okay, I want to get this data set stored in this format. Did it work? And you can look and see if it did, and if it didn't, try and troubleshoot it. Like I said, easy to work with multiple data sets and files, and you can keep track of all of them. And it also provides some easy to access information on what Python functions you're wanting to use. I'll show that off a little bit in demonstration. But anytime you're starting to write out a function and you're like, hold on, I forget what input variables I'm supposed to put in here, you can just highlight it and then press a command and it'll pop up essentially the like source code, the description of that function. And like I said, we'll see that in a little bit. Pros and cons: easy to view and access active variables, what imported files you have active, any recent plots, and can carry variables between multiple Python codes. We can talk about that a little bit as well. It also, like I said, can provide some instant and detailed help on the Python functions, and doesn't require an active internet connection to, save and run the codes. Cons: it can be very visually overwhelming to new users. If you look at this, it's a lot to take in at first, but a Jupyter notebook definitely has, allows you to be introduced to the code in a more gradual fashion. So it can be a bit overwhelming to look at, especially for new users. And although the code can still be run in blocks, like Jupyter Notebook does, the method to do so isn't as intuitive, unless you know to look for this little, number sign to percentage signs. It really doesn't, Spider isn't necessarily set up to already have that going. You just kind of have to figure it out and then start using it. And then any explanation of any code that you want to describe has to be what's called commented in. And we can show that in a bit, that just there's a way to kind of describe a line of code without actually having it be run. So quick kind of back and forth or kind of summary of Jupyter versus Spider and PyCharm. Jupyter, definitely a better visualization and introduction to Python code. The files themselves can act as both, an active like Python file, and also as a bit of a visually helpful presentation product. It also encourages splitting codes into separate blocks for easier troubleshooting. Spider, more in-depth tools for working with multiple data sets. It's easy to view information about any active variables you are working with, and it provides some instant help if needed for writing out certain Python functions. So like I said, we'll be showing some demonstrations of both of these next, but I just wanted to see if anyone has any questions, or have to put some questions in there if they have them before we get going with the demonstration. So we just have the first one, why not Git? I'm thinking for instance like GitHub and just like the Git platform in and of itself. I'll say Noah and Joshua could absolutely chime in. I know right off the bat, GitHub is really good with, from what I understand, storing and sharing Python packages and code and functions.
Yeah, the thing I would say about Git is, if you're going to be working on projects with people beyond just yourself, you'll probably need to learn how to use GitHub. But in terms of basic running and writing code, GitHub is not a Python compiler. It's not an IDE. So it's not, it is something that is good to know, and maybe could be covered in the future, but yeah, it's not really within the scope of this first webinar.
And there's that, is Anaconda the only platform for Python distribution, or are there other platforms available? To my knowledge, I mean, I know Conda in and of itself is, I think, the most widely used of the Python distributions, aside from just installing Python just raw and just directly. I'm sure there are probably others, but
Yeah, there's a virtual environment package manager that
that's
sort of
right.
comes with basic with Python. There's also other sort of more comprehensive package managers. I think Poetry maybe is one. I'm sure there are others out there, but Conda and Anaconda are kind of the most widely used ones and the sort of ones most recommended to start with.
We have Rob Harris. Can the same code be loaded into either IDE? So yeah, so you can open and edit and run Python code in either Jupyter or Spider. I think Noah and Joshua can elaborate a little bit more, but when it comes to Jupyter,
Yeah, I mean, when I do the Jupyter demonstration, you'll see what the code in it looks like, but the actual syntax of the code is the same. It's just when you are writing code in a Jupyter notebook, it gets saved as a .ipynb, which is a slightly different format. I'm not sure if you can open a .ipynb with Spider or a different IDE. So if you want to move your code from Jupyter to, say, Spider, you might have to just copy and save your code into a simple Python script, a .py.
are there any differences in language between Spider and Jupyter? Can you work in both the same code? So yeah, that kind of is pretty similar. They both use Python. They both use the same syntax as far as the actual code is concerned. Jupyter just has that extra functionality of, being able to transition between some descriptive, actual, just like, straight up letters and words, leading into Python code. While Spider just, here's the code, run it. So you can definitely work in both of the same code, but yeah.
So Jeffrey's question, he has Python 3.68, doesn't need to upgrade to Python 3.9. Python versioning, the main differences are between, say, Python 2 and Python 3. Between like individual versions of 3, it's more, there just may be certain packages that do or don't work with specific versions of Python or subversions. So I think generally if you are running, say, version 3.68 and all your packages and everything is working with that, there's no real need to upgrade to the newest version each time a version comes out, because there may be packages that you're using where the owners of those packages, because once a new version of Python comes out, the owners of all those packages have to go and make sure that their package works with the newest version. And so sometimes that takes some time for people to do. So no, you don't have to upgrade the newest version of Python every time it comes out.
Yeah, I think the main thing is, for a lot of the older Python 3 versions, the main updates that are coming out for each one are just security updates. And so as long as you're staying up to date with 3.6 or 3.8, from what I can understand, they're both still accepted and terminology, but yeah, they're both still worked on and accepted. So yeah, how many hours of practicing Python will you advise for a beginner?
I would say rather than focusing on the number of hours, just try and do some interesting projects that you enjoy with it. And so that might be, some simple data analysis, making figures, whatever. Whenever there's things that you need to do, just trying to do them in Python is the best way to learn.
Yeah, and
At least that's what I find. I mean, other people may feel differently.
Yeah, and I think probably when doing a couple of hands-on pet projects here and there could improve your ability to know a lot of things. You might know certain things not from the basic, but then as you keep doing it, you have a lot of information out there on Google to be able to find your way around things, and you will learn faster. So I don't think the number of hours is dependent on the timing you have. If you're a student, you work and you're trying to just put some hours out of if you really want to transition and become an expert, I think you can spend as much as hours as you want at the end of the day.
Yeah,
absolutely.
Maybe I'll take this next question. So the next question is, what is the market demand for Python expert as an employment? I think that knowing how to code in Python is very good, both in academia as well as in industry. Me specifically, I'm running a startup now, and we do our entire tech stack in terms of the analysis and stuff that we do is all in Python. And I think that is true for a lot of startups and companies. I mean, obviously there are other coding languages that different companies will use as well, but Python is, I'm not sure on the exact stats right now, but it is either one of the most widely used or the most widely used programming language, depending on the sort of sector that you're in. So I think there is a huge demand for it. And I think even if you're not intending to work explicitly as a sort of software engineer or whatever, that knowing some Python will always help you.
And I think with the wide range of different fields, either being a data analyst, a data scientist, a machine learning engineer, or AI, it depends on the level of expertise at the end of the day and its application to your field.
All right, we have another one. Thank you for your presentations. Which of the code environments, Jupyter and Spider, do you actually use? I primarily use Spider. I have some experience with Jupyter. I did an internship over the summer where I was just primarily working in a Jupyter notebook just because I was legitimately making a coding tutorial. And so it just was the most straightforward way to go. But yeah, I'm primarily Spider.
Yeah, I use Jupyter to do sort of code development. Like when I'm trying to build code that I don't currently have, I'll do it in Jupyter just because it's a lot easier to troubleshoot and make it work. And then once I have something that is working, I'll save it as a .py, which would be like a Python script that could be opened by an IDE. And then I'll integrate that .py into like the rest of the code base. But I always start with Jupyter just because for me, it's the easiest and quickest way to develop something new.
And then Joshua, you also use Jupyter a lot, right?
I basically use Jupyter Notebook. Yeah.
So any introductory free online course you would recommend? So I know that as far as videos go, I have nothing that comes to mind, but I know I think it's like W3 Schools or something like that has a very extensive Python tutorial that goes through basically every aspect of beginning to code in Python. Is that one? Noah and Joshua, I'm not sure if there's any other ones that you.
I think you can go for Udemy. I think Udemy has a lot of free courses you can do. And at the same time, I think Udacity have some kind of scholarship they give for certain nano degree courses. So you can pick that and you can work with that. And also Datacom, I think.
I think Coursera is also a good online platform that has some pretty strong courses on it. Some of the courses on Coursera are free, some of them you have to pay for, but it's not very much. And then one of the things I like about Coursera is that they have basically the same courses as are taught at certain universities. Like did a machine learning class at Stanford while I was there as a grad student, and there is the exact same course available for a very low price on Coursera compared to doing it at Stanford. So we can share some information afterwards to all the registered attendees. One thing I was thinking though is I think we should move on to the demonstrations soon and then come back to the questions after those, just because there may be some of these questions that are answered in our demonstrations.
So I will stop sharing then because I think
so
Joshua, it's up to you.
Yes, I will share my screen now. And so I'm gonna first just walk through like how to get Jupyter Notebooks set up and running before I actually before I give my little demonstration of it. All right, can you guys see my screen? Cool. So this is the download page for Miniconda. And I personally have never actually used Conda, the whole version with the graphical user interface, because I just generally don't use graphical user interfaces. I would rather just use the terminal. I'd rather use just direct scripting. So to get set up, you would first download, the appropriate Miniconda installer. And Miniconda comes with the package manager, it comes with Python, it comes with some basic packages. So once you have that installed in your terminal, you would first create an environment. And this is like what all your packages and everything will be inside. And so actually, I guess before I just run that command, the way to know that Miniconda and everything installed properly is if you try and run Conda and it shows you that your terminal found it. If that's the case, then you can create your first environment. And you can call it whatever you want. Here, I just called it SEG_v1. It's asking me if I want to proceed. And so now I have this environment created and I can activate it. And so now if I do any installation of packages or if I do anything, they'll all be within this environment called SEG_v1. And the reason you want to do package installation and everything inside an environment is that, I guess, one of the, there's a few questions in the chat about MATLAB versus Python. And MATLAB, is very widespread in industry and or not in industry, in academia. And in some industries as well, they use MATLAB and more, maybe, yeah, I'm not sure, but there are industries that use it as well for doing research or development. And one of the main advantages MATLAB has is all the packages and everything are installed. You don't ever have to worry about sort of installing additional packages, whereas with Python, you do. And sometimes the act of installing packages, if you have a certain version of one and you want a different version and you install the other version, now you have two different versions of the same package installed, it can cause issues. And so using a package manager and virtual environments solve this by explicitly installing each package to a specific place. So now that I have this environment created and active, I'm going to install. So you can see here, these are the commands that you would use to install the different packages that I need. This command installs Jupyter Notebook. This one installs NumPy, which is a very basic sort of math package. This one installs Pandas, which is used for manipulating databases, or not databases, used for manipulating data files of a variety of formats, and is Pandas and NumPy are sort of two of the very basic Python packages that probably everyone will use in Python. And then matplotlib is this package used for plotting data. So I'll just run one of these commands just to show what it looks like. And then I'm going to switch over to an environment that I already have made. So you run conda install NumPy. And so here it's saying this is the environment it's going to get installed into, saying that my conda is out of date, which, like I said before, you don't always have to update every single version. This is the list of packages it's saying it's going to install. And you see there's, NumPy, and then, or these are packages that are going to get downloaded. And so the main thing is NumPy, but then there's also, each package has a number of dependencies, which are other packages that package needs to work. And so NumPy is the main thing I want it to download. And then all these other packages are its dependencies. And then this is just saying what is going to get installed. So I'll hit yes. And it's normally pretty quick, but for some larger packages can take a little bit of time. And then especially if you have a lot of packages already installed, because then it has to sort of check what versions are going to work and what dependencies you already have or what needs to be updated. So in this case, it was pretty quick. But that is how you would install all these packages. But now I'm just going to switch over to a different environment that I use for work that already has all this stuff installed. So the way to actually run Jupyter Notebook is you just type Jupyter Notebook. And then it is running, while it's running this in the terminal, it's going to bring up my browser. And then here you can see any existing Jupyter Notebook files, which have this extension .ipynb. You can also make new ones, but in this case, I'm just going to show one that I already have made and just kind of walk through how Jupyter Notebooks works. So as Chris said, the code in Jupyter Notebooks is run in these sort of cells. And the nice thing about it, I don't have a lot of HTML in here right now, but you can have a cell which you put as markdown. You can put all sorts of HTML and formatting that you want in here. This one is just a script that I've been using internally to do some analysis. So I just have comments in the code, which is something Chris mentioned as well. And this is just when you lead with the hashtag symbol, it just doesn't do anything with the text after that. So the text after this hashtag read in the data is just a comment that I wrote and is not anything that is going to get run. The first thing you need to do, whether it's in Jupyter Notebooks or if you're writing a function just to run from the command line or anything, is to import the packages that you want to use in your script. And so here, the ones I want to use are Pandas, NumPy, and matplotlib. This syntax here, import Pandas, that just imports the package you want to use. But something that is very commonly done is you add this as PD. And what that does is it then allows you to call that package. So in this line over here, I'm now using the imported pandas package, but I've shortened its name to PD. So instead of typing pandas.readCSV, readCSV is a basic pandas function, which allows you to read in data. So instead of typing pandas, I can just type PD. And people just do this because it makes it faster to type things. So the way you run specific cell is you can either just click the run button or you can hit Shift Enter. This little, so when you run a cell, the number here next to it turns to a star while it's running. And then once it's done running, it's a number sort of showing what cell has been run last. So because this is the first thing I ran, it shows a 1. If I run it again though, it shows a 2 this time. And so now that I've run this, PD, pandas, numpy, matplotlib are all imported and I can use them. So this first thing I'm going to do is just read in a file that has some data. And so what this file looks like is just a list of buildings and then some modeled flood depths. And so this is a pretty large data file. You know, I think there are, I don't know exactly how many. There's a lot. And so if you're trying to do something with this file manually, it would be a nightmare. It'd take you forever because there's, you know, 100,000 buildings or something. And so when I run this function, which is a function that pandas has default, this read CSV function, and then all I do is I give that function the path to this CSV, which is a comma separated file format. So now it's reading that in. And so now if I type df, which is what I saved this to, I see the results. And yes, there's 116,000 rows. So these buttons are how you add and remove cells. This plus button adds new cells to run. And then the scissors cuts the cell so you can paste it somewhere else. So this is going to be a bit more sort of advanced, maybe, coding than we've covered so far. But this is, you know, a very real world example of I had some data and I wanted to make a figure. And so I think later there's going to be, you know, more explanation of some of the basic data types. Chris, correct me if I'm wrong.
Yeah, there will be.
Yeah. So some of your questions I'm sure will be answered after that, during that period. But basically, this is just how Jupyter Notebooks works. And so, you know, you can run things out of order. Like I ran this cell after running the first one twice. So it says 3. You know, if I run the next cell, you know, it says 5 because there was a few, you know, cell in the middle that I ran and then deleted. And so if I go back and run this one again, which at this point it doesn't do anything because I've already imported these packages, it now shows 6. One thing about being able to run stuff out of order is that you can cause problems if so this line of code right here is there's a column in this data frame that I didn't need, so I just dropped it. And if I run it again, it doesn't work because I already got rid of that column. And now when I try and run it again, that column's not there, so it throws an error. So that is one thing that can make using Jupyter Notebook a little more confusing, is if you are not keeping careful track of the order that you run things in and you try and run something again, because you already ran it, you can have errors that kind of sneak up on you. So if I load this again, and then I run this one again, now because I reloaded the data frame, now it works. Here I'm using some logical Python, you know, I'm using a for loop and an if statement, which are some of the sort of fundamental building blocks of how you do things in Python. And this is, again, just to, you know, you see I'm using this df.drop. I'm just, again, getting rid of some columns in my data that I don't want. And while the syntax seems, especially if you've only used MATLAB or if you don't have really any coding experience, the syntax maybe seems a bit confusing, but there's a lot of good tutorials out there. And once you start actually using it yourself, it is not that hard to learn. And this is, again, just doing something with the columns, just, keeping some and getting rid of others. And I think, maybe the best, I'm just going to go through this kind of quickly to show the final result. And then after we go through the other demonstrations, when we're back in the question period, if there are, more specifics of Jupyter that people have questions about, then we can use this to sort of show exactly how that works. And so what I'm doing with this code is I basically, how did I freeze? Okay, I think I'm unfrozen. So what I'm doing with this code itself is I have this list of buildings and then I'm just trying to see at different time in the future, based on sea level rise, what buildings are flooded or not. And so at the end, this is now using a different package, and the syntax here is, I'm not going to go into it because there's kind of too much to cover right now with just the basics that we're going over. But at the end, what I can produce is a figure that is showing a time series, and this is something that I actually used in a proposal. So it just goes to show that I think even using very basic open source free stuff from the Python community, you can make very valuable visualizations that I've used Python and exactly matplotlib to make figures both for papers as well as proposals, both in academia and industry. So I think it's a very useful thing to learn. A few other things I'm going to quickly cover. One of the things that's nice about, say, Spider or an IDE like that is you can see all your, or MATLAB, for instance. This was one of the things that made it hard for me when I first switched to Python from MATLAB, is I couldn't just see all my variables in the window on the side. And so Jupyter has some things to make that able to do that. The very basic built-in function is locals. And so what locals does is it just returns everything that Python can currently see. And so this is each data frame, data frame, which is what Pandas calls like a table with data. Each data frame that I defined, you'll see in here with like a brief description of it. But there's also a lot of things like, what modules you imported. And, there's a lot of other stuff in here that makes this kind of confusing to work with. So rather than locals, you can run this command, %who, and it just shows you a list of all the variables that you've defined. And if you do ls, it shows as a list. And so these are, just the variables that I defined above. And then you can even filter it more, where you can type who ls string, and that shows you just the variables that you've defined that are a string. So now if I type call, okay, that's what call is equal to. These are the variables I defined that are a list, which are another sort of basic data type that we'll go over. And so if I type one of these, it will show me what's inside that variable. Another, so I said data frame, that's another, is that gonna work? Yeah. So that's another, that's like the pandas data type of a table. And so if I type one of these, it shows the table and everything that's in it. So this who ls command and who is very useful to sort of see what's going on, and just showing you what variables you've currently defined. And there are other plugins that you can use, which will, there may even be some that show this as like a table somewhere that updates automatically. I don't use some of these fancier Jupyter plugins, but I know there are a lot out there which can make your life easier. So I think that is what I'll show for now, and we can either take some more questions or move on to the Spider demonstration. Maybe we should just get through all the demonstrations and then just take questions at the end. What do you think, Chris?
I think one thing I'm also going to start doing is as we're going through the rest of these demonstrations, whoever's not presenting, if there are any questions in the chat that you want, or in the Q&A section that you want to type out an answer to, just so you can at least start getting through some of them, because not we're going to be able to get through
there's a
spend
lot
all
of
the time you want on
questions.
all 23 questions. But we can just kind of start to, any ones that seem like they're going to require a little bit more time, we can address separately. But
Yeah, or questions that are maybe ones that are not repeats or whatever. We'll go to those first or something.
yeah. All right. So
Cool. I will stop sharing then.
thank you so much for that, Noah. So now what I'm going to do is do a quick little demonstration to kind of show how, let's see, is everyone seeing my screen?
Yep.
Cool. So Noah did an excellent introduction to kind of using Miniconda and setting up the environment for that. I just kind of defaulted to using Anaconda because when I still installed it, I was like, I don't know what I'm doing. So I just installed it and it has everything right there. And I just continue to use it because at this point, I don't know. It's just here now. So when it comes to Anaconda, once you've downloaded it, you can search your computer for the Anaconda navigator, right? And that's going to bring up this this thing right here. That's what it is, showing the right screen, right?
Yeah, you are.
Okay. All right, cool. It's my first time trying to do the whole dual screen presentation. So this first page that you're seeing, right, just kind of shows all of the different software that you can install to run on whatever environment you're using. It automatically installs just the space root environment, but you can easily create new ones by going into this environments tab here. And one of the good things about Anaconda is that you're able to see all the packages that it downloads, and then be disgusted by the amount of packages that it downloads. Because I think there might only be 4 or 5 that I installed here that weren't already on Anaconda. And then you can go non-installed and see, oh, almost 9,000 packages are available if you want to quickly get them in there. But this is a very, a very, easy way to kind of see what packages you have installed, quickly, mark them to be removed or to upgrade if you want to do that. But this is a nice, easy way just to make sure, okay, this package did get installed, it is active, I can use it. So from here, right, you can kind of do whatever you want. And actually, quickly, it might take a little bit to create a new one. Let's see how it goes. You can do create. If you want to do a new one, so let's do like what Noah did. We'll do SEG test. You could specify what version of Python you want. Doesn't really matter. I'll just go with whatever its default is. And it'll take a little bit of time to create. And there'll be a set of just kind of default packages that'll install. When I've seen it doesn't use all the ones from the that are installed in the base environment when you first install it. So see, it's just 11 packages that it starts with, right? Pretty straightforward. So now, if you want to install something new, you have to go through the fun bit of, you can either, go into kind of Python terminal and do all the stuff that you were seeing that Noah took care of, or you can just install something that just quickly launches a terminal with your active environment. So it says SEG test. And then let's say if you want to install NumPy, you'll find that there are a few ways you can do it. Either with like conda install NumPy, or there's also this package called pip, which is a very kind of quick way to get a lot of packages as well. So you can do that. And that's all well and good. And then you can exit out and refresh and see So you can update. And if it doesn't work, I'm gonna look very foolish. And there we go. Now you can see that NumPy is in there and it's working properly. But similar to Noah, I'm just gonna go with it's the root environment or another one that I've been using. So you can see, like I said, all the IDEs that we've been talking about, Notebook and Jupyter Lab, Spider and PyCharm at the bottom. So you can go to, once you already have whatever you want installed, you can go and launch it. And then, boom, you have Spider. It's already gonna, whatever functions or codes you already had open the last time you had Spider running are already going to be open the next time you open up Spider, unless it just had a major crash for some reason. And so we're just going to kind of look quickly at this one here. This one is just a very basic, I'm going to input some electrical resistivity data and just run a filter on it to see what data, get rid of any bad data that might be in there. See if I can show what that data is supposed to look like. Well, that one's somewhere. There we go. ERT, that. All right, so this is the data file that we have. It's just a typical output from a Syscal resistivity unit. Bunch of measurements, right? A whole bunch of fun stuff. How to save as a CSV file. Now for Spider, it's still the same thing. Any packages you want to use throughout your code, you want to make sure you import them first, just to make sure they're used. Same thing,
Chris, is it possible to increase the fonts, the screen? I think.
Yeah, I can
Okay.
do that. See if I can just zoom in. There we go. All right. So as with, as how Noah showed in his Jupyter Notebook example, importing your packages, as some kind of shorthand, not only does it make it faster to type, but I think it also helps if there's any codes or any functions with that happen to have the same name. I'm not sure how Python usually tends to handle that, because just become used to having a shorthand, so that if you happen to import two packages that both have like a read CSV function, that's just chaos. So the main things we have, pandas and NumPy, as Noah was using, and also matplotlib, pyplot. This is just one of the more widely used ways of visualizing data and just creating some plots. So you do Control Enter to run that. You can see the terminal on the side that basically does a similar thing to Jupyter Notebooks. See which cell, the order that the cells are run in. And then, like I said, this whole hashtag and 2% sign thing allows you to block off sections of your code. So I have a section just to import my data. What I just kind of do is I just define the path that my, where exactly on my computer that file is located, the name of the file, just because I have a ton of them. I want to get the folder first, and then as I start to load in file names, can just do that separately. And then as I won't go too deep into all the functionality, but we can see after we run it, you have this variable explorer thing here, which just you're able to see the name of the variable that you've imported or that you have active, the type of variable it is. So the thing that I call data is a data frame. And you have to open it up. If you double click it and see all the columns, all the data, you have to see if it's a string or a list, and Joshua will go over those terminology soon. And then you kind of get to see how it's structured, right? So it's very helpful just to, in similar fashion to MATLAB, right? Just seeing the variables that you have defined and making sure that they are imported and defined properly. So now we just chose a specific column that we're working with, and then plotted some of the data. And so once it's run, it'll tell you where you can go for it. And wow, look at that. Look at that horrible ERT data. Yeah, it's a fun time. People with any reason to background are like, how do you have an 800% deviation? Yeah, it's a fun time. So this is kind of like, I at least wanted to show this off a little bit of just showing how, Spider looks, showing the variables that you can use. If anytime you're using a function and you're not sure what the input for it is, like, if you're doing a scatter plot, you want to plot that scatter, you can highlight it. It was Control I. Well, it sometimes gives a little bit more. Let's do that. All right. Well, depending on the function you use, it can. There you go. Press Control I. It can really just give you the full, help rundown of here's the function, here's the different input parameters you can put in to specify what you want to do with your figure or other stuff. It'll define all the variables. It's a nice, helpful way just to quickly see how a function should be set up without constantly going to the page for whatever package you're using to double check it. I'm going to stop right there. I could go a little bit more, but we're only have 20 minutes left. I want to make sure Joshua has the time to go through some data structures. So Joshua, if you want to take care of that, I can assist in helping to answer some questions in the meantime.
Okay, I think probably I just run through this and then maybe after which we can answer all the questions. So basically what we're doing is to run through a kind of outline here. I love to make things a bit plain with a lot of text so that you could use it. You're going to have access to this particular Jupyter script, and I kind of put a lot of things you get to do hands-on to improve your understanding more. So I will talk about basic syntax, some of the rules when it comes to naming and so on. We'll look at data types and command operators we use, and we'll look at data structures and so on. So like Noah have shown, you need to import certain libraries, like importing NumPy here, it's NP or Pandas if you're going to deal with data frame. And basic syntax, and I think one of the first words you learn in Python, it's print hello. I have this as a string here, and I want to really print this. All you need to do is that the print function just gives you the output of in a particular line. So I'm printing the words hello world, print. You have this output here. Now, when you look here, you have the executed time it takes this particular cell to run. Now, it's important when it comes to dealing with a lot of computations to write simple codes that will not take a lot of time to process. You can see the timing it took and the time and so on. And how I used to put it, I have this contents that will give you all the different headers you have. Now, if you want to do this header like Noah showed, all you need to put is you just put a #1. It's a kind of like heading you put like you have a big header, you have sub headers and so on. So with this, and then you have to turn this particular from code. The default is code, but you have to make it to be a markdown. And then once you do that, the shift enter gives you the first header, and then you can continue whatsoever you're doing. Now, generally, we have Python keywords and identifiers. Sorry, I have to be a bit fast because of the time. Now, we have what we call keywords in Python. Now, these are already built-in functions that when you're trying to name certain variables, you don't, you're not allowed to use it. So the first thing you do here, I can import the keywords to see the entire list of the keywords I have in Python. Once I type in import keyword, I will print keyword.kw list. Now I have different keywords, about 36 of them, I think I captured here. False, known, true. True, false are all booleans that I use. You can use def to define functions. You can use logical operators like and, or, not, and so on. You have a return, which returns the function of either a while loop, or you're defining your user-defined function, and so on. Now, what we mean here when you're naming a variable, for example, is I want to define something. I said, let's say I define it SEG webinar, something like this, webinar. Now, if you look at here, we said keywords are reserved words in Python. We cannot use a keyword as a variable name, a function name, or any other identifier. And I think somebody asked that question in the Q&A. So all you need to do is what we're saying is you cannot use, for example, a leaf here to define something. Once you type in a leaf, it turns the Python turns it, because it's already a built-in keyword, it makes it green. So when you click on elif equal to, let's say 35, I will comment this, and you click on execute, you'll discover that you have a syntax error telling you invalid syntax. Now, this is basically because you're using a particular keyword to do that. So it's Python, I will say Python is case sensitive. So when you're naming, ensure you avoid the use of these 36 words you can see here when you're naming your variables. Now, there are certain rules with regards to naming variable. Now, you ensure that you can start with capital letter, small letter, doesn't matter. But then you cannot name, I can have SEG underscore when you're having compound words. You can use underscore to connect the two, SEG web, and I put equal to 35. Now, when I run this, I will need to print this, copy this and put it in the print function here. I'll have it will return the value of 35 for me. But now, if I don't follow that law, I decide to separate this. Can you say I take off the underscore here? Let's see what it returns for us. Python complains there's an error because of the naming convention. So whenever you're having a lot of compound words you need to put, there's no limitation, but ensure that you use an underscore. And then secondly, you cannot use a number to start naming a variable, like using 0, this to define. You cannot use a number. Something like this, I put, it will still complain. Python does not support that. So I think I mentioned a couple of stuff down here. Looking at the identifiers, I made a list here. An identifier can start with a letter from A to Z, and then you can always use an underscore here, followed by different numbers or whatever you want to use to define the variable. An identifier cannot start with a digit like I showed you above. Now, keywords cannot be used as identifiers, and symbols like this can also not be used. For example, if we want to use a symbol like this, maybe you try to copy this and we put it in a new cell. And I put this symbol, I try to name this, it will complain. If you try to put add, it will still complain because it violates the rule of your naming of your identifiers. So you ensure that you maintain the right way to write all syntax, to write all identifiers and variable. Always obey the rules. Now the webinar, and then secondly, look at this particular stuff here. I said Python is case sensitive. I think I mentioned that. Now I defined webinar. When you look here, I started with a small letter and I said it's equal to 3. But on this line, now I can toggle this to see the number of, I used to do that so that it could help me to see the line numbers so that I can make reference normally. So in order to toggle almost all these functions, all you need to do is you have to install, I think, MB extensions. You can do that from your terminal. I think pip install MB extension. You can Google this, and once you do that, you can be able to see a lot of all these functionalities to add, so that you can have a good script that people can actually follow in case they want to really go through your work. Now, we define webinar here 3 with small letters. We define webinar here with capital letters. Now, when we return this, you discover that returning webinar with small letter returns the one captured above. But if we return the one with capital, it will return the one below. So you must ensure that it's case sensitive. You need to be careful. For example, I define webinar here as 3, and then below here, okay, I think because I've already run it, I use another example, sorry, just to show us something. I copy this. Okay, so I have a variable here which I assigned a number 3 to call binary. And then I want to call in this variable, but with a capital letter because I made a mistake here. So let's see if Python will recognize it. Because it's case sensitive, then Python will tell you that this is not found. So you have to go back to ensure that what you captured at this point is what you're actually writing here for you to have the right right results you need. So we need to change this to small letter b, and then you have this. Now we have what we call multi-line statements, kind of statements in Python. Typically, you kind of write a lot of things and you have them all written from beginning to the end, and you just want to try to break it into different lines, into new lines. So for example, we have something here I call, let's say I have A equal to, I will leave all this uncommented for us to, you can use it later when you're going through using the script. I define A, and then I define it as a string, and I put SEG, and I don't want to continue it. All you need to use a backslash this to separate it, and which shows that you have entered into a new line. We can say we have another string here called webinar, and I need this to be in another line again. I'll put another backslash here, and then it takes it to another line. So it's important to do this so that you can separate what is here, and Python will know that this is continuous. You know, when you're writing in English, when you get to the end of the line and you have this compound words that you need to write, you know, you put this hyphen to show that the word is continuous in the other line. So this is just typically what we are trying to do right here. So if I take this and I run it and say, it gives me the result: geophysics, geology, and hydrology. Now, another important thing is the use of quotation in Python when you're defining your strings. Now, it's either you use one quotation, or you use the double quotation, or you can use the triple quotes in trying to define things. Now, I use certain example here. I think uncomment all this. Now, I define word here. I put it into a single quote here. The second one, sentence, we put it into a double quote, and the third one, you put it into a triple quote. Now, when we run this, you can see it's running. But for example, what we see here below is I write the word hello world, and I put the first line, I put a single code, and then at the end, I put a double code, and I run it. It tells you that there's an end of line error here. You have a syntax error trying to tell you that this is not right. But then you might, all you need to do is to make this one, and it works. But in case you have a lot of words you need to write to put them in the string, I can put hello world is good. Something like this. Hello world is good. Now I have to, and I'm trying to put, let's use my words. My world best footballing. So something like this, and you're trying to combine words here because it's personalized. Now you discover that when you put one string here and you've started with one, it shows that this entire sentence actually stopped at this point. But you want to capture all this entire line as a string. So all you need to do is you put a double string at the beginning, and you have a one string, and then you put and you close it here. Now, by closing this works because it assumes that the single string quotation mark it's in here, it's part of this entire stuff. But if you don't do it, you put a double like I highlighted, you always have error with regard to that. So you have to take notes of that. And then I think another most important thing is making comments generally in Python. Now we use the hash sign to indicate comments. Now when we say comment, I think no one mentioned that. All you're trying to do is trying to give more information about what you're actually doing. Now we're trying to describe what we're doing. All we're trying to do, for example, I have an equation here of porosity here, where we say porosity is equal to the void ratio of the rock over the total volume. And I want to really look at this. This is what I'm trying to do. I will write, I'm describing the equation of porosity. You say, so anybody that's looking at my script knows this is exactly what I'm trying to do here. Now, you can define a function to execute this equation. For example, I will say define porosity here. Now I have to put the arguments, the keyword arguments within this bracket here, and the keyword arguments are going to come from the values you're seeing from the equation. I'll put kind of VV, and then comma, I will put VT here to show that this is what I'm trying to do. I define a function. Now there's what we call a doc strings here. This is it, and I try to bring it up here. Now doc string is just, you put it inside the defined function to give more information about the formula you are, whatsoever you're defining within the keywords, within this bracket here. Now what I'm doing is I've defined a function called porosity with an argument total volume and the void ratio. So I need to define it so that anybody that's looking at what I'm doing will understand what I'm doing. So I'll put VV. I'm defining it as void porosity, sorry, void ratio. And then my VT, I'll put it as the total volume of the rock. Now, the doc screen tells us information, and then all I need to do is return the equation I have here as, come back here, VV over VT. So you take this VV, and then we divide it by a VT. So what we've done is, now what Python does is it ignores this as a comment. It's just giving you information. So it does not account for this when it's executing this particular function. So you can put your comment as this before you start writing for people to understand. Or another way you can do is, I want to put it outside here. You need to put the hash again, and then you can type anything. This is porosity equation. So if I execute this particular cell, Python does not recognize, it doesn't take this into account. It doesn't take this into account, and it doesn't take the docstring as well into account. So all it takes is this. I hope it's clear. Now we come to data types and operators.
Joshua.
Yeah.
Sorry, we have a minute left. So I think we're gonna have to save the data types and operators probably for the second Python workshop.
That's fine, this one.
But so I just want to, kind of just quickly go over a few things. I know we have a lot of unanswered questions. Apparently, whenever we did a typing answer, it just went back just for the person who asked it to see it. For people who want like copies of this example notebook or of some example codes, my understanding is that we'll be sending whatever things we're able to share with people. We'll throw some example stuff into a Google Drive folder or Box drive, just to have people have some resources to kind of play around with. Lori, from what I understand, that the recording, once it's processed and available, will also be shared to all the attendees, correct?
That's correct.
All right. So I know
Actually, it'll be on the SEG YouTube page, and it'll have its own playlist.
awesome. Is the will a link for the SEG YouTube page be included in like the exit survey sort of deal?
Sure.
Cool. So I want to thank everyone for coming. I know we kind of had to rush through a whole bunch because we tried to fit a whole bunch into this one. There will be other open source workshops. The next one on October 18th, I believe, is looking at QGIS. There will also be another more advanced Python workshop. I believe we have it scheduled for December. I
believe it's the 20th of December.
Yeah. So with that one, we'll talk more about the, we'll basically pick up on Joshua's talk about data types and structures, because some of the open source software we'll be using after that will require a little bit of that background knowledge. So keep an eye out for that. We'll stay in touch. Keep an eye out for SEG near surface emails. Is there anything else I need to?
Yeah, I was just going to say, for some of the questions, if people couldn't see the answered ones in the Q&A, we will, I just copied and pasted them all. And so we'll send out the answers to the questions that we did answer that people were not able to see when we send out the recording as well.
Yeah. Or when we do the whole like exit thing, there'll be like a survey or whatnot afterwards. We'll include a link to the stuff for all the example codes, and probably it's like a Word document that has all of the stuff for just like our answers to a lot of the questions. So sorry we weren't able to get to all of them and spend a lot of the time that we wanted to on individual questions, but thank you all for coming. Hope you all at least gathered something. We'll have our emails in there too, for people who want, I'm not gonna go ahead and say, oh yeah, spam all of them, but like, I'll have my email in there. Anyone else who wants to, throw it in there just to have any follow-up conversations, more than happy to have them. Sorry for running late. Thanks for everyone. Lori, Noah, Joshua, not sure if there's anything else needs to be touched on before we wrap up.
Thank you everyone for coming. I hope you enjoyed it.